In this video, we're going to work on the ALEKS problem called naming and drawing branched alkanes. There are two different versions of this problem. One version is where we're given three molecules and we're asked to come up with their names, which is what we're going to work on first. Another version of the problem is where it's giving us the name and it asks us to draw the molecule. So let's do the naming first, and let's start with this molecule down here. It looks like it's the easiest. When we are naming a straight chain molecule, the first thing that we need to do is find the longest continuous chain of carbon atoms. That is our parent chain, and we want to number that chain of carbon atoms in such a way, left to right or right to left, so that any substituents that we have are on the smallest possible number. So I'm numbering this one from left to right so that our substituent, methyl, is located on carbon number 2. If I numbered from right to left, like this, our substituent would be located on carbon number 6. And again, we want our substituents to have the smallest possible location. Once we have our carbon chain numbered and we have our substituents named, we're going to put the molecules named together. We're going to start by locating and naming our substituents. We have one substituent named methyl, and it is located on carbon number 2, and we indicate that by writing the location followed by a dash and then the substituent's name. And then after that, we name the parent chain. This is a 7-carbon parent chain, and a 7-carbon chain is heptane. Let's go up to the first molecule in this problem. Our longest continuous chain of carbons is right here, and we are going to number from either left to right or right to left so that our substituents will have the smallest possible set of numbers. If we go from left to right, our substituents are on carbons 3 and 5. If we go from right to left, our substituents are still on carbons 3 and 5. In this case, it means it doesn't matter if we number left to right or right to left. I'm just going to go left to right, like that. Once we have our carbon chain numbered, we can locate and name our substituents. We have two identical substituents, two methyls. When we have two of the same substituent, we use the prefix di to indicate that we've got two of them. Now we're ready to put the molecules named together. Our substituents are located on carbons 3 and 5. We're going to use a comma to separate the numbers, 3, 5. Say the substituent's name, including the quantity, dimethyl, and then the parent chain, which is another heptane, 7-carbon parent chain. Now, last but not least, we have this one right here. Now, this one, I'm not super confident that this is the parent chain. I think that this is the parent chain, but because it's got kind of a funky branch here, I do want to count and make sure that I am choosing the longest chain of carbons. If this is my parent chain, that is 1, 2, 3, 4, 5, 6, 7, 8 carbon chain. Let's just double check this right here. That would be a 1, 2, 3, 4, 5, 6, 7. Let's double check this. 1, 2, 3, 4, 5, 6. Okay, so this is our longest parent chain. It never hurts to check. We want to number so that our substituents have the smallest possible number. And I think that we're going to accomplish that by going from left to right. 1, 2, 3, 4, 5. That puts our substituents on 2 and 5. If we go the other way, yeah, that's definitely not what we want to do. This way would put them on 4 and 7. So we want to number from left to right, 1, 2, 3, 4, 5, 6, 7, 8. We have a 2-carbon substituent, which is ethyl. We have a 1-carbon substituent, which is methyl. When we're putting the molecules named together, we alphabetize our substituents. Ethyl comes before methyl alphabetically. So ethyl is going to come first in the molecule's name. Ethyl is on carbon number 5. And we're going to follow that up with the methyl on carbon number 2. When we're naming molecules, we always use commas to separate numbers from each other, and we always use dashes to separate numbers from letters, and we put no spaces anywhere in the molecule's name. Now, this name for a lot of students, at least initially, is counterintuitive. A lot of students think that they should they should put the substituents together in terms of numbering priority. So the methyl should have come first in the name because it's on 2, and the ethyl should come second because it's on 5. And that's logical, but it's not how we do it. We put them in alphabetical order. Okay, so this is one version of the problem where we're naming. The other version of the problem, we're going to be given a molecule's name and asked to draw it. And let's go check this out in ALEKS. So this is the other version of the problem. It's asking us to draw a condensed structure, not a line structure, of 6-chloro-2-methyl octane. Now, when I'm drawing a molecule from its name, I always start with the ending of the molecule's name first. That is an octane. That's what I want to start with. So I want to make an 8-carbon chain for octane. And so I am just going to, okay, be careful. I am going to put 8 carbons together in a row like this. And ALEKS is going to make me do 1 carbon at a time. What am I up to? 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. There's my 8-carbon chain. Now I'm going to put the substituents on the carbon chain. So I'm going back to the beginning of the molecule's name. It tells me I have on carbon number 6 a chlorine. So I'm going to find carbon number 6. 1, 2, 3, 4, 5, 6. I'm going to put a chlorine right there. And then it says 2-methyl. So that means on carbon number 2, I have a methyl, which is a CH3. Now, this is not, I'm not done. This isn't it. I'm not done. My parent chain, I started by just putting carbon atoms down, but those carbon atoms have hydrogens on them, and they need to be there in order for this problem to be correct. So I need to go back and change all of these carbons to the correct group, CH3. My second carbon, carbon number 2, right now it only has 3 bonds, so that means I need to have a hydrogen on there, so that needs to be a CH. The next one is a CH2. Actually, the next few are CH2s. This one is a CH, there's another CH2, and there is my CH3.